Bismillahirrahmanirrahim. In this video, I will solve a question based on latent scale design. In the latent scale design, we have one treatment variable that is represented by A, B, C, D, and we have two blocking or nicest variables which we want to block. So an industrial engineer is investigating the effect of four assembly methods of a television assembly, and we are interested in minimization of the assembly time. We have taken four different operators for this study. For example, the engineer knows that each of the assembly method produces fatigue or stress, so that the time required for the last assembly may be greater than the time required for the first one. So we have taken the order of assembly as our blocking variable as well. So in the latent scale design, we must have equal number of all of the variable. For example, there are four levels of the order of assembly, four different operators, and four different assembly methods. I will solve this problem in Minitab software. So first of all, we have to do the data entry, write the name of the variable, so order of assembly. In order to save the time for the data entry, always write the column first, then row second, treatments on the third. So you can see it here. The order of assembly is the first, operator is the second, and the treatment A, B, C, D is the third variable. So now we are going to do data input. So since we know that for each order of assembly, we have four different operator, 1, 2, 3, 4. So the order of assembly 1 will come 4 times. So you can write here 1, 1, 1, 1 for the 4 time. Then 2, 2, 2, 2, 4 times. Likewise, 3, you will have to write 3 for the 4 time, and the 4 again for the 4 time. Then operator. For the order assembly number 1, we have 4 different operators, 1, 2, 3, and 4. So write here 1, 2, 3, and 4. Then copy it and paste it 3 more times, so that your 2 of the variable input will be completed. Now you're only left with the assembly time and the entry of assembly method. So how you will do it? So you can see it here. The first observation is at 1, 1, C is equal to 3, and then 10. So these two input have been already done. So you will have to write here 3 and 10. So 3 and 10. Then come down right here. So 1, 2, you will have to write 4 and 14. So you can see 1 and 2 has been already done. So save your time and write 4 and 14. So for the third observation, just write 7, 1, 7, 2, 8. So 1, 7, then 2, 8. Then write here 2, 7. So 2, 7. Then write 3, 18. 3, 18. Then after that 4, 11. So 4 and 11. Then write 1 and 8. 1 and 8. After that, write 1, 5, 2, 10. So 1, 5, 2, and 10. Then write 3, 11. So 3, 11, and then 4, 9, 4, 9. And then write 4, 10, 1, 10. 4, 10, 1, 10. And the last one is 2, 12, 3, 14. 2, 12, 3, 14. So once you have done with the data entry, now the next step is the analysis. In order to perform the analysis, go to stat, then go to ANOVA, GLM, general linear model, fit general linear model, select your response, that is time. After that, select the factors, order of assembly, operator, assembly method. In all of these, click on the graph residual, because first of all we do the analysis of the residual. Then in the result, go to the simple table. Instead of simple table, go to the expanded table, because in the expanded table we get the percentage contribution of each and every factor. Then click OK, and now waiting for the results. So these are the Minitab result. We have 3 factors, all of them are fixed, and each of them has the 4 levels. Come down initially and have a look at the residual plots. So we can see it here that our residual analysis depicts that the data is somehow normally distributed. This graph shows the residual versus observation order. that there are no specific pattern, no 6 points are continuously above this central line at the 0 residual or below it. Please remember that above this 0 there are positive residual, and below this center dashed line there will be negative residuals. After that, the residual versus fitted value. In this observation, again you can see the number of positive residual are somehow equal to the number of negative residual. It means that the variation in the data is constant. So we satisfied the assumption of the homogeneity of variances. Now we are coming towards the model summary. So model summary explains that 84.82% variation in the assembly time has been explained by assembly method, order of the assembly, and operator type. Now ANOVA, analysis of the variance. In the analysis of the variance, we make our decision based on this p-value. So now you can see it here. We usually keep our significance level or cutoff value at alpha is equal to 5%, and the p-value is less than 0.05 depicts that variable or the parameter is found to be statistically significant. So here we can see that the operator has a p-value of 0.01 and order of assembly has a p-value of 0.004. So these two variables have a statistically significant effect on the assembly time. Now the next step will be the regression analysis. To go to stat, regression, fit regression model, select your response variable, then select your predictors, order of assembly, operator assembly method. Hey, nothing have to do, click OK, because we have already done with the residual analysis, and don't do it again and again. Since only two values are found to be significant in the analysis of the GLM, so keep only those parameters while doing the regression analysis. Initially, you can do it 3. Why I did initially? Because I want to show you some other methods, just like, because here you can see the p-values are different. So maybe you will have to apply some different methods. So you will go to the stepwise. In the stepwise, select the criteria. In the criteria, use BIC. This is a Bayesian. And sometime with the help of these over parameters, if you want to see them significant, the result may be significant, or try all these different criterias and the result that are found to be interesting or as per your willingness, so you can use them. So here you can see that if we're using the Bayesian, only assembly method is found to be significant and has been kept in the regression equation. So it's up to you people. Now the last thing, in order to make the graph, because using the graph we can select our optimal points for the optimization. So go to stat, ANOVA, and main effect plot. In the main effect plot, again select your response variable, select all of your 3 parameters, click OK, and you will get the graph. So in the graph, how you can decide about the optimization. So since we are interested in the minimization of the assembly time, so we will select only those settings that will minimize the assembly time or which have the least mean. So you can see order of assembly level 3, operator number 1, and assembly method number 1. They have the least assembly time. So we will select this assembly method 3, operator 1, and order of assembly 3, operator 1, and assembly method 1. These are found to be our optimal settings. Thanks for watching the video. Have a good day. Bye.